Okay, let's look at a couple problems to our last review that kind of goes over the last chapter we just did, which was the trigonometry. So the first question says, what is the value of the 6 trigonometric functions for angle A in the triangle below? So we want to know what is the sine of A, what is the cosine of A, what is the tangent of A, and then what are their flips, so the cosecant of A, the secant of A, and the cotangent of A. So we know from SOHCAHTOA what sine, cosine, and tangent are, and then we could just, of course, flip them to get the other ones. We just have to figure out what's opposite, what's adjacent, and what's hypotenuse in our triangle. So everything is dealing with angle A in this case. So 16 is obviously the hypotenuse. It's the longest side. It's across from the 90. Now this side across from the angle will be the opposite. We do not know the value of that. We'll have to find that. And then this is, of course, the adjacent side. It's the side next to it. So the first thing I do is I try to find that missing side. So that's 16 squared equals 10 squared plus that missing x squared. So 16 squared, 16 times 16 is 256 equals 100 plus x squared. So then I'll subtract 100, which gives me 156 equals x squared. So then when I take the square root, x is going to be equal to the square root of 156. And if I break that down, doing my radical simplification, that's 2 square root of 39. And that's again just doing the factor tree. If I did that over here, that's 4 and 39, 2 and 2. So we have a group of 2's that comes out and a 39 that stays inside. So this side is 2 square root of 39, the opposite side. So then we can just start writing those sides over here in our ratio. So we know the sine is the opposite over the hypotenuse, so that's 2 square root of 39 over 16. The cosine is 10 over 16. The tangent is opposite over adjacent. And then for the cosecant, secant, and cotangent, I can just flip those. So 16 over 2 square root of 39. This would be 16 over 10, and we could certainly reduce some of these. And then 10 over 2 square root of 39. So you can certainly reduce some of those fractions, but I'll leave that to you to try. Alright, problem 7 here, or 2, we're trying to solve the triangle below. And what we see here, we have an angle. We have an angle of 40 degrees here in the corner. We have this 7, which is the opposite side of 40. And we really want to find all the sides and all the angles. So I want to find this side and this side. Now y is the hypotenuse and x is the adjacent. Now the other angle is really easy to find because we know all the angles add up to 180. So if we just do 180 minus 90 minus 40, that'll be our 50. So this angle is our 50 degrees. Now to find the sides, it'll take a little more work, so I'm just going to pick one arbitrarily to find first. I'll find the hypotenuse first, which is the hypotenuse, and I'll use this opposite side because it's the only one we have a number for. It's opposite of 40. Now if we think which of our trig ratios is opposite and hypotenuse, that is sine. So I could say the sine of 40 degrees is equal to the opposite over the hypotenuse. Now sine of 40 is just some number, so I could type that in the calculator and I get 0.642, and then I could write that over 1 equals 7 over y. And I simply cross multiply. So that would be 7 equals 0.642y. And then I would divide both sides by that decimal. So divide by 0.642 on both sides. So I get 10.9. So the length of the hypotenuse is 10.9. So that side is 10.9. So now to solve it, I just have to find the adjacent, and I could do that any way I want. I'm going to go ahead and use this opposite side again, and of course I'll use the adjacent. So opposite and adjacent is our tan ratio. So if I'm setting this one up, it would be the tan of 40 equals the opposite, which is 7, over the adjacent, which is x. And then basically this is the exact same problem. So tan of 40 is 0.839 over 1 equals 7 over x. I'll cross multiply. So that'll be 7 equals 0.839x. And I'll divide by 0.839. 0.839. 7 divided by 0.839 is 8.34. So that 8.34 is my other side. So now I know all sides and all angles. Okay, this problem says I want to find the measure of angle L in the triangle below. So I want to know what this angle is. Now what I do know in this is I do know the opposite side of angle L, and I do know the adjacent side. I do not know the hypotenuse, although I could certainly find it. But the opposite and hypotenuse we know is tangent. So what I know is the tangent of angle L is equal to 25 over 50. That's opposite over adjacent. And if you recall, when you have the ratio, when you have the trig ratio and you want the angle, we simply take the inverse tangent of that. So we'll just take the inverse tangent of 25 over 50, or we could certainly do a half, because 25 over 50 is a half, and we get 26.6 degrees. So find the angle pretty easy. You just set up the ratio, you take your inverse trig ratio. Okay. Number 4 is one that we can use the unit circle. What is the exact value of cosecant of 60? So if I look at my unit circle, and I go to 60. 60 is over here. And I look at that point, and it's a point of half, comma, square root of 3 over 2. Now if we remember, what's given in this point is the first one is the cosine of the angle, and the second one is the sine. Now cosecant is not given, but what cosecant is the flip of sine. So all I'll have to do is I look at the sine value, which is square root of 3 over 2, and I'll just flip it. So it's 2 over the square root of 3. And if I wanted to clean that up, we remember we can multiply top and bottom by square root of 3 to get rid of the square root on the bottom. So that's 2 square root of 3 over 3. Because the bottom is the square root of 9, which is just 3. Alright, 5 says find the value of secant 8/3 pi. Now, I don't know what 8/3 pi is. It's not on my unit circle. So what I'm going to do first is I am going to convert that to degrees. So remember, to convert to degrees, we'll multiply by 180 over pi. So those pi's will cancel. So I'm really taking 8/3 times 180, which is going to give me 480. So really, the secant of 8 pi over 3 is a secant of 480 degrees. Unfortunately, that's still not on our chart. So what we said, if it's not on the chart, you can add or subtract 360 till you get a number that's on the chart. So I'll subtract 360 because I obviously want it smaller. So that'll give you the secant of 120. Now 120 is on the chart. If I go over to 120, it's right here. And the point is negative half, positive square root of 3 over 2. But secant is the flip of cosine, so it's the flip of the negative half. So it's negative 2. All right, number 6 says if cotangent of theta equals negative 7, what would be the value of tangent? When we have a problem like this, it's going to be very similar to the ones we did before. We just have to draw our own triangle. So I'll draw a little triangle like that. I'll put theta in the corner, any corner you want, which makes this the opposite of theta. This is, of course, the hypotenuse, and this is the adjacent. Now, we really don't need the hypotenuse in this case, because if you remember cotangent of theta is adjacent over opposite. So adjacent over opposite in our case is 1 is going to be 7 and 1 is going to be negative 1. And you could actually reverse these, but we'll just keep it like this for now. So the adjacent is 7 and the opposite is negative 1. Now the tangent is just the opposite over the adjacent. So really we just have to flip this thing to get negative 1/7. But if we did want sine or cosine, or secant or cosecant, we could certainly find that hypotenuse using the Pythagorean theorem. Okay, a couple problems on functions of sine and cosine. So we have this function, y equals negative 2 sine 8x, and we want to talk about amplitude and period. Well, really, these two numbers really are going to help us figure out those two things. Now, the amplitude is always the absolute value of the number in front, so it's the absolute value of negative 2. Now, absolute value just makes things positive. So the absolute value of negative 2 is just positive 2. That's how high and low the graph is going to go. Now the period for any sine or cosine wave is going to be 2 pi divided by b. And this is kind of our b value, this is our a value. So we're really going to take 2 pi divided by 8. And then 2 over 8 just simply simplifies to pi over 4. All right, this one's a little different. We basically want to figure out what equation would be best modeled here. So the first thing I would look for is I would figure out what's one period. So I'm going to start up here, and because it starts up at the top, I know this is going to be a cosine wave. If it starts in the middle, we'd say it's a sine wave. So this kind of travels down like this, and I'm going to keep tracing it until I get it to repeat, go back to where it started, which is right here. So this is my period. Now, the amplitude, the number that goes in front, is pretty simple. It's basically just how high and how low does this thing go. And in this case, it is 3. So I'll put a 3 in front of my cosine. That'll do the amplitude. Now, the period is how far it is to repeat. And it seems to repeat, in this case, every pi units, because that's where it starts to repeat. So I want to put a number in front of x here that will give me a period of pi. Well, remember the period of function is 2 pi over b, so we're trying to figure out 2 pi divided by what is going to give me pi. Well, that of course will make b 2, because 2 pi divided by 2 gives me pi. So I'll put a 2 there, and that would give me this graph. So if you were to graph this in Desmos, you would see this function here looks just like this graph here. So hopefully this is helpful for you. Please let us know if you have any questions on the basic trig.